All right, so continuing on with problem number 1, we found in part C that S equals 40 plus 4W plus 300 over W. And in letter D, they wanted you to draw a graph. All right, so I've already done that for us, but the point of this was to show the local minimum point. So what we would want to do is plug that equation into y equals into our calculators. And unfortunately, my calculator is not working, so you're not going to be able to see it on your screen. All right, but you should be able to follow along with me and type it in yourselves so that you can see it on your own screen. But if you were to type that equation into y equals and plot it on the graph, this is kind of what it would look like. Some of the main points are at 5, 120. The second one's at 10, 110. The third one is at 15, 120. And the last one is at 20, 135. But if we wanted to find the local minimum, okay, what we could do is do second trace number 3. On our graph and find that minimum point. And what we would find is that the coordinates would come out to be about 8.66 and 109. So at about x value of 8.66, the y value is at 109, and that is our local minimum. Now in part E, they want you to find ds dw, which again is just a fancy way of asking you to find the derivative of s. So if we look at the equation for s, the derivative of 40 is 0. The derivative of 4w is 4. And now before we can take the derivative of 300 over w, we need to rewrite it. We need to move w to the top. And when we do that, the exponent becomes negative. So it becomes 300w to the negative first. And if we take the derivative of that, we would get minus 300w to the negative second. So that would be ds over dw, or the derivative. Now in part F, if we wanted to find the value of w for which s is a minimum, okay, this is getting into that process of optimization, which we did in Unit 6. And if we want to find the value of w for which s is a minimum, we would set our derivative equal to 0. So we would say that 0 equals 4 minus 300w to the negative second. Okay, then we would type it into our calculators again into y equals, and we would want to find where our graph intersects the x-axis. And if you were to do that, okay, you would find that the coordinates would be 8.660. Okay, you should kind of make a connection up to letter D. All right, they have the same x coordinates. Now letter G says write down the value L of the parcel for which the length of string is a minimum. If we go back up, we know that L can be written as 150 divided by W, as seen in part B. So if we simply plug this W value in, do part G down here, L would equal 150 divided by 8.66. And it comes out to be about 7.3 centimeters. And then similarly, in part H, if we wanted to find the minimum length of string required to tie up the parcel, all right, if we go back up to our equation for S, we now know W from part G, or excuse me, from part F, so we just plug that in. So H, we would do S equals 40 plus 4 times 8.66 plus 300 divided by 8.66. We get an answer of about 109 centimeters.